Yeah, good morning. This is Dr. Subramanya Rao, Professor, EC Department, Sasi Institute of Technology and Engineering. Yeah, the next classification is causal and non-causal signal. Yeah, a continuous time signal. First, let us start with continuous time signal. X of t is said to be causal if the signal x of t is not defined for t less than 0. It means the signal x of t is defined only for positive values. Only for positive values of t. That's the meaning of x of t equal to 0 for t less than 0. Means it is not defined for negative values of t. It means it is defined only for positive values of t. Then the signal is said to be causal. If this condition is not satisfied even for one value of t, then the signal is said to be non-causal. It means if the signal is defined even for one negative value, then the given signal is said to be non-causal. So like this, it is very easy to define the causal signal. We can take n number of signals, n number of examples for it. Suppose x of t in continuous time, x of t equal to e power minus 5t into u of t. What about this? It is causal. What is the reason? Here u of t is defined because of u of t, the limits of e power minus 5t is 0 to infinity. For all positive values of t, the signal is defined. For negative values of t, it is 0. So that's why it is causal signal. Like that, you can take another example. Suppose x of t equal to sin phi t. Any value, sin phi t. Here, sin means unless it is multiplied by u of t, the sin phi t is defined from minus infinity to infinity. Sin phi t means with specific value, it is defined from minus infinity to infinity. So for all negative values also the signal is defined. So we can take it as, we can consider it as non-causal signal. Non-causal signal. Like this, you can take some other example. X of t equal to u of t plus 1. U of t plus 1 means what? U of t plus 1 is, it starts from t equal to minus 1. This is equal to minus 1. Now what about this? Here it is defined for negative values also. Minus 1 to 0, the signal is defined for negative values also. That's why it is non-causal. Like this, you can take n number of examples for continuous time signal, whether it is causal or non-causal. Okay. So any signal that is multiplied with u of t is considered as causal. Similarly, any signal that is multiplied with u of minus t, multiplied with u of t, multiplied with u of minus t, it is causal, it is non-causal. Blindly you can say whatever may be the signal, if any signal is multiplied with u of t in continuous time, that is causal. Multiplied with u of minus t, that is non-causal. Okay. Similarly, we can see the same concept for discrete time also. Yeah, a discrete time signal x of n is said to be causal. Same concept. If the given signal x of n is 0 for n less than 0, it means if the signal is defined only for positive values of n, then the signal is said to be causal. If the signal is defined even for one value of n for negative, then the signal is said to be non-causal. X of n equal to 0, it means should not be defined for n less than 0, negative values of n. Then the given signal is said to be discrete time signal. Here also you can take n number of examples for it. Similar to the previous one, x of n equal to 1 by 5 whole power n into u of n. Here the signal is multiplied with u of n. It means the limits are 0 to infinity. So no negative values are defined for the given signal. So it is causal. Similarly, it means if any signal is multiplied with u of n, default we can say that it is causal. Similarly, you can take another example, that is 1 by 5 whole power n into u of minus n minus 1. So try to observe the difference between continuous time and discrete time. In case of continuous time, I told you, if anything is multiplied with u of t causal, multiplied with u of minus t is non-causal. Whereas in case of discrete time, if any signal is multiplied with u of n, that is causal. If anything is multiplied with u of minus n minus 1 is non-causal. You can easily see the difference in continuous time and discrete time, because in case of continuous time, if you take a signal, suppose for example, if it is a signal u of t, it means 0 to infinity. What is the negative part? 0 to minus infinity. So straight away both u of t and u of minus t starts from 0. So this side 0 to infinity, no, that is something multiplied with u of t. 0 to minus infinity. 0 to minus infinity. That's why it is u of minus t in case of continuous time. Whereas in case of discrete time, what about the concept? Same concept. First samples, no. So 0, 1, 2, 3 up to infinity. Up to infinity. So 0 to infinity. That's why it is denoted as u of n. No doubt at all. But on the negative side, what is the next sample after 0? Minus 1. Minus 1, minus 2, like this. Sample at minus 2, minus 3 up to minus infinity. So here negative part starts from minus 1 to infinity. Minus 1 to infinity. Minus 1 means u of minus t, u of minus n minus 1. So 0 to infinity, positive side, minus 1 to minus infinity. Starts with minus 1 because no sample is there in discrete time between 0 and minus 1. So starts with minus 1 negative part. So that's why that is denoted as u of minus n minus 1. It means it starts from minus 1 to minus infinity. So that's why in discrete time, if any signal is multiplied with u of minus n minus 1, that is non-causal. Like this, we can easily find out whether the given signal is causal or non-causal. Next, let us go to the last signal. The last classification is even and odd signals. Even is also called as symmetric, odd is also called as anti-symmetric. So first let us start with continuous time. A signal x of t is said to be even if it satisfies the condition x of minus t equal to x of t for all t. It means if a signal is reversed with respect to time, and then if it is equal to x of t for all values of t, then we can say that it is an even or symmetric signal. The best example here is a cosine signal, cos. Best example. Cos is symmetric with respect to vertical axis. It means if you put a mirror here, on both sides the signal is equal. Even if I reverse the cosine signal with respect to the vertical axis, then it will be same. So x of minus t, reversal of the signal, is equal to the original signal for all values of t. That's why it is called symmetric or even. On other side, we can define the odd signal or anti-symmetric signal. For that, x of minus t is equal to negative of x of t. negative of x of t. The best example for it is sine. You can easily understand. Sine means it starts like this. Suppose this is sine signal x of t. If it is reversed, it means x of minus t. What is x of minus t for it? It means positive with respect to this. These two are exchanged. So positive part comes to the negative. Negative part comes to the positive. That is x of minus t. Observe, x of minus t is not equal to x of t. That's why it is called odd signal. Red and blue colors are not equal. When these are equal, if the given signal, blue color signal is reversed with amplitude, it means minus of x of t. Minus of x of t means what? If you reverse the blue color signal with respect to amplitude, it means up and down exchange, then it will be equal to red. So that's why x of minus t is equal to negative of x of t. But directly x of minus t reversed signal is not equal to x of t. Negative of the x of t, then the signal is said to be odd signal. The best example is sine. Sine omega naught t. Here the best example is cos omega naught t. So it is very easy to identify. With respect to the vertical axis, if a signal is equal on either side, then we can say that even, otherwise it is odd. Let me show some of the examples for even and odd. This side, these are all even signals. Observe here, with respect to this vertical axis, on either side both parts are equal. This side is equal to this side. So that's why it is called even. Similarly, with respect to the horizon, this side samples is equal to the this side samples. Okay, that's why these are all examples for even. Similarly, this side odd. Sine already we have seen. Next, observe this side part is exactly opposite to this side part. Minus of x of t will be equal to x of minus t. Okay, similarly in discrete time. Like this, we can take several examples for even and odd. Additionally, for even and odd signals, we can find out even and odd components in a signal. If you take a signal x of n, if you take a, suppose in discrete time or continuous time, any signal x of t contains even and odd part. Any signal can be represented as a sum of even part and odd part. xe of t plus xo of t. So from this, you can easily find out even and odd parts of the signal by calculating x of t and its reversal signal x of minus t. It will be xe of t minus xo of t. If you add these two equations, suppose it is first equation, second equation, if you add these two equations, 1 plus 2, we will get xe of t, that is xe of t equal to half of addition of the signal and its time reversed version. And if you subtract these two signals, we will get odd component of the signal xo of t. xo of t equal to same half of x of t minus x of minus t. So like this, if any signal is given, we can easily find out even and odd components of the given signal by using this formula xe of t and xo of t. Let us see one example for easy understanding. Yeah, you can take this example x of t equal to sin 2t plus sin 2t into cos 2t plus cos 2t. we can find out the even and odd components of the signal. So what is the formula for even component? To find out even or odd component, ultimately we require the time reversed one, x of minus t, x of minus t. So it means t replaced with minus t. Sine 2t, 2 of minus t, minus sine 2t, minus sine 2t into cos minus t equal to cos 2t only. Cos 2t plus cos minus 2t is cos 2t only. Okay, here sine minus t is equal to minus sine t, that's why it will be minus here. Whereas cos minus t is cos t only, so that's why plus is like that only. So this is x of minus t. Even part, how do you get even part? Half of x of t plus x of minus t. If you add these two, observe what will happen. These two cancelled out, these two cancelled out. Only thing is 2 times of cos 2t. 2t cancelled out, we will get cos 2t is the even component. Similarly, odd component, x of t is equal to 1 by 2 of x of t minus x of minus t. Subtract the two components, subtract these two. What will happen? Minus of minus becomes plus, 2 sine 2t, minus of minus becomes plus. So 2 times of sine 2t into cos 2t minus cos 2t and minus cos 2t. So here cos 2t cancelled out. 2 times 2 cancelled out. So that is answer is sine 2t plus sine 2t into cos t. So in the given signal, cos 2t is the even part, sine 2t plus sine 2t into cos 2t is the odd part. Like this, if we add these two, xe of n plus xo of n will give the original signal, x of n. Like this, we can find out even and odd components of any given signal. With this, the classification of the signals is completed. In the next class, we will start operations on signals. Thank you.